Pens and enclosures. Pens and enclosures can in some ways be considered as transitional structures between ponds and cages, insofar as environmental and stock control are concerned. Used for cultivation of yellowtail in Japan, a milkfish in the Philippines, a salmon in Norway. Not successful in many other countries. Also practiced in Israel, Scotland, and many Asian countries. Its drawbacks include difficulties in the use of intensive techniques, high costs of embankments, water management such as through pumping. Success depends to a large extent on the hydrological conditions of the site. The design of the structures and operational procedures have to be based on adequate knowledge of water quality, floods, waves and currents, prevalence of predatory animals, etc. Probably the simplest and relatively most efficient type of enclosure used for aquaculture is the one formed by damming a bay, cove, fjord or arm of the sea, estuary or river. Sites are selected where the barriers can be constructed across narrow sections, or channels, in order to reduce costs and increase the ease of operation. Most of the perimeter of the enclosure is formed by the natural shoreline. When the blind end of a water area is enclosed, there may be only one series of barriers, but in enclosures that permit direct flow through there may be two series of barriers, one upstream and another downstream. The dams are constructed with stones, earth or concrete, depending on the availability of materials and exposure of the site to storms and other natural disasters. They hold screens consisting of vertical aluminum or galvanized metal bars, with about 1 centimeter gaps between them to allow free flow of water. The screens, which are removable, can be located in the concrete by molded guideways. 2 guideways are provided, one behind the other for each screen, to enable a duplicate to be placed in position before removal for cleaning. The screens prevent the escape of the fish stock. For proper management, these enclosures have to be relatively small, 2 to 7 hectares, although there are much larger enclosures in Japan, measuring up to 120 hectares or more, which should strictly be called ranches or reserves rather than farms. The depth of water in different portions of the enclosure differs, and the circulation of water in the deepest parts may be insufficient to prevent the accumulation of waste and organic matter, giving rise to oxygen depletion in parts of the enclosure. Suction pumps have been used successfully for removing such accumulations, and additional flow-through has been created by propellers mounted on floats. Obviously, this increases the cost of operation. Another type of enclosure or pen is the one formed by net barriers to partition off areas of an open water body, such as the intertidal areas of the sea or foreshore areas of lakes and reservoirs. Different designs of enclosures have been constructed. But, generally, the enclosure is formed on one side by the shore and on the other 3 by a wall of nylon netting hung from poles driven into the sea. In many such enclosures, concrete or stone walls about 3 m wide are built on each side where it joins the shore to provide adequate support for the net. Around the rest of the perimeter, heavy posts of impregnated timber or concrete piles are driven into the bed by at least about 3 m, extending for about 2 m out of the water at all times, during floods and high tide. Using bamboo scaffolding, enclosures of different sizes have been made in the lakes. Because of the shallow nature of the lakes, enclosures can be fairly easily constructed. An improved floating net enclosure has been developed, where the net enclosure is held in place by concrete block sinkers, about 500 kilograms in weight, with a series of small weight on the foot rope which is secured to a chain link between the sinkers. The net is kept afloat by floats attached to the head ropes. Several circular pens consisting of a bamboo framework and purlon nets have been built in the freshwater portion of the lake by small-scale farmers.